Before we talk about single-phase transformers, you should know that there are some instances where a single-phase transformer has a very different application than the typical residential applications in the discussion to follow. We'll address these specific applications later in the lesson. Now, in most cases, the service supplied to single-phase customers is rated at 120-240 volts. 120-240 volts is a secondary distribution voltage that provides a customer with two voltage options. 120 volts, which is typically used to power electric lights and small appliances such as television sets, microwaves, and toasters. The 240 volt connection is used for high-load appliances such as electric ranges, electric dryers, heaters, and air conditioning units. Heavier single-phase customers might also include small business shops that can have 240 volt air compressors, light-duty welders, and power equipment like saws and hydraulics. In order to provide these two voltage options, the individual windings that make up the secondary winding of a single-phase transformer must be connected together in a certain way. The two windings in a secondary of a single-phase transformer are typically labeled winding AB and winding CD. We'll use this simplified illustration of the primary and secondary windings in a single-phase transformer to demonstrate the internal connections that were referred to as conventional transformer wiring. Now, here's the primary winding in the unit. One end of the winding is connected to the H1 bushing on the transformer. In this example, the other end of the winding is connected to the H2 bushing on the transformer. Here are two individual windings that make up the secondary winding of the transformer. There are three secondary bushings mounted on the unit. Inside the unit, an end of one of the secondary windings is connected to the X1 bushing. An end of the other secondary winding is connected to the X3 bushing. The remaining ends of both windings are joined together at the X2 bushing. In an additive polarity transformer, the winding A lead is connected to X1. The winding B lead is connected to X2. Winding C is also connected to X2. And finally, the winding D lead is connected to X3. In this way, the windings are connected end-to-end or in series. In most cases, the X2 bushing has at least two connections on the outside bushing. One connection is to the tank ground just a few inches below the X2 bushing. The second is the neutral connection from the X2 bushing down to the system neutral. Each winding connection, X1 to X2 and X3 to X2, provides 120 volts. A connection between X1 and X3 will yield 240 volts. With this in mind, we can begin to see what the secondary bus supplied by this single-phase transformer will look like. It will consist of three wires. One wire, usually referred to as the neutral, is connected to the ground and the X2 bushing. The remaining wires, generally called hot legs, are connected through leads to the X1 and X3 bushings.